Yesterday we did the graph, we did the ArcCosine and its inverse, and this picture is just a little short of perfection. So yesterday I did something, so I'm going to show you what I did and the result of that picture. Okay, and I think I copied and pasted to the file, but I just couldn't find it right away. Okay, it should be this piece. Okay. Okay, so that's the better picture. Okay, that's the better picture for it. Wait, where did I put it? Oh no. How come it doesn't paste? Wait. Okay, so let me do it again. So that picture would be a, would be the better picture because we don't want to have that impression. We don't want to have that impression that, so this is the red, green. So this is the one. Okay, this one, okay. I should copy and paste this way. Okay, so copy. So I'll get you the picture, okay? There. All right, so this is the picture we got yesterday with that piece chop off. Okay, that piece should not be there. But anyway, but it's because I open up this area, therefore the cosine curve will come over. But in the ideal world, which I, kind of created this ideal situation, which is that the red is a cosine between 0 to pi, and the green is the arc cosine. We plotted all the points, okay, and I hope you will find them useful, and I'm certain it will. So that picture, okay, with some marked points, should be in this place, okay. This one, I marked the point, I marked some points with Zoom software, but now you can see after I mark it with the same software with the scientific notebook, so you get to see those points, okay. And your next quiz certainly has something to do with it. So without further ado, do you guys have any questions?
I have 2 questions.
Okay.
The first question is, when I was doing the graph, when I was plotting the points, I didn't really understand where it should go. Because when I'm looking at my own graph I made in the class, it shows like different points within the homework graph. So I was wondering if you can go over the points.
Okay. In terms of points, you first of all, we need to understand what's the input or what's the output for each curve. Okay, what's the input and what's the output for each curve? For the cosine curve, over here, right? This piece is a cosine curve with the red dots. Okay, so let me just change that color to red. Okay, the cosine curve is red. Okay, the cosine curve is red. We're crossing out these pieces because we only look at from 0 to pi. Okay, so this piece. So let me bring this other thing over here. Okay, I'm going to bring this piece over here. All right. (125%). All right. When you look at the red curve, we know that's the cosine between 0 to pi, right? That's the cosine between 0 to pi. For that piece, the input is angle, the output is what? The output is ratio. Okay? The input is angle, the output is ratio. For example, for pi over 3, for example, right? Pi over 3. Pi over 3, let me bring that over here. How do we graph the piece? How do we graph pi? How do we plot the points of pi over 3? Right? We would, so this is from A to D, right? ARD, A to D. Pi over 3, from pi over 3 to the ratio, okay, ARD. So A is the angle, pi over 3. For pi over 3, you would measure the angle counterclockwise, and we terminate here, and we pick a point on the terminal side of the angle. I'm quoting definition, and we find a point. And that point we found is half the x coordinate, √3/2, that's the y coordinate. X over r is the cosine ratio. That's how we get a half, right? So that's how we get a half. So we take that arc length, okay? We take that arc length, which is orange. We have done orange consistently for some time, right? So this piece of arc length, straighten it up, okay? Straighten up that, the orange. So this orange is the angle in radian, okay? The arc length, same value, okay? You get that? And the cosine ratio is half. The cosine ratio is half. That's half. This red is half. It's what is a half? On this picture, that's half. So these two reds are the same. Okay, they may not be exactly the same because this one is a little shorter. Okay, visually they should be visually and in practicality. Actually, they are the same. Did you get that part? Everybody, this is the fundamental. Okay, this is the fundamental. You get it?
So how come this already a point for pi 3 then?
That's right. So when we mark this point, how do we mark this point? When we mark that point, okay, so this point, the input is always a horizontal measurement from the point of reference. The output is a vertical measurement. So this point will be marked as pi over 3, which is the orange. And the ratio, the cosine ratio is half. That's how we mark the point. So all the points on the red, on the cosine curve will be marked as input A angle, output ratio. So all of the red points are marked that way. Does that make sense?
Kind of, but I'm still confused because now when looking at it, now there's 2 pi 3s on the table. It's only 1 pi over 3. So which point is the actual point?
This red dot
Mhm.
is The horizontal is pi over 3, the vertical is half.
So then what's the other pi over 3 then? So is that is that not the
Where's
actual
the-
point?
Where's the other pi over 3? The other, oh, this should be pi over, wait. I think I made a mistake. Yeah. This point should be put over here. This red, my bad. So this pi over 3/2 should be this one. When I was putting this here, that's in the wrong place. You're right. I understand why it confuses you. Okay. So let me get rid of this one. I'm sorry, guys. I did make a mistake. Okay.
So does that mean for the arcsine 1/2 pi over 3 is also wrong? Because when I plot the point, it should be next to 0 pi over 2.
This mark, this mark,
That is pi over 6 root 3 over
that should be
2.
pi over 6. Okay, it's my mistake. Okay, the pi over 3 should be here. All right, so never mind about this one. Let me do it all over again. I made a mistake. I apologize. It's a good thing I think I haven't published the quiz number 16, right? I will need to double check that. Okay, so let's go back here. I'm still going to bring back this picture. Okay, so this should not confuse you. This should not confuse you. I will need to make some adjustment. So what I was trying to do, I was trying to mark the points on using the same software so it doesn't shift when I move around. So this point is pi over 6. Okay, this point is pi over 6. Okay, hold on. I'm sorry, guys. Is everybody with me? Do you guys understand my mistake? It's just I marked this point in the wrong place.
Yeah. So do you think it's possible to go over arcsine 2 just in case? Or would that be too much? Or do you want to do that? Or you want to do that after?
I can do arcsine, but I didn't think I made a mistake there.
Okay.
Okay. Well, you go back there. You should be able to judge my mistake if you understand what I'm talking about here. I'm not saying I absolutely don't make any mistake. I could make a mistake. Because marking these points, it takes me a long time to get this right. So I have to do it over and over and over again to manipulate the software. So in this case, I didn't make a mistake and I apologize. Does everybody understand?
Yes, Professor.
Okay, so this point. Okay, so now we look at the red curve, everybody. Okay, we look at the red curve. The red curve, this point, let me use arrow. Okay, this point is 0, 1. Pi over 6, root 3 over 2 is this guy. This guy is over here. And that guy is over there. Is that clearer?
Yes.
Yes? Everybody? So in terms of marking the points, I don't think I made that mistake yesterday in class. I did not, Peruse, just in case. It's just this morning, because yesterday after class, I spent a long time to put those points together. But in that process of manipulation,
That's true.
You guys couldn't imagine that, because to manipulate with this software. So I'm not gonna, I don't want to sounding like giving excuses to myself. I should not be making that mistake. It's just you have to check the point back and forth. Okay, and in that process, I made that mistake. So is this clear now? Because I'm not just giving you the right answer. I'm also giving you the tool to judge my work, your work. Do you follow me?
That also shows us how much we learned by.
That's right. We learn from our mistake.
It shows Jacob is catching it very well.
Yes, very good job, Jacob. But so in that case, in that sense, so this morning when I pointed out this point is pi over 3, so this point is pi over 3. So are you still confused, Jacob?
No.
Okay. Yes, there is absolutely this correspondence. Okay, so this is half. There should not be a situation, there should not, because this is a one-to-one function, there should not be a situation that you have the same input and different output. You're absolutely right, okay? So I made a mistake of marking that point in this place. Did everybody understand my mistake? My mistake is I marked this point over here. That's a mistake. On the other hand, that point, okay, is, I just let this to be on the record, is pi over 6. Root 3 over 2. All right. Are we good?
Mhm.
Any
Thank
more
you.
questions? Any more questions?
Thank you, Professor, for correcting real time.
Absolutely. I make mistakes. My policy about making mistake is as soon as I see it, and I correct it right away. There's no point to struggle it because math is either right or wrong, right? There's no gray area that I can be right or it can be wrong, where I can be in between, and I would try to struggle, say, oh, I'm right, yeah, but yeah, I don't do that. I never do that. Okay.
Yet, Professor, we know this working with scientific, notepad, whatever it is
Right.
just giving the point, moving the arrows and all those things. You have to multitasking. I cannot believe how you do that.
It's okay. Yeah. I have excuses, but forgive my excuses as well, right? And the reason I want to introduce the other picture is because you understand why? Because I have this little red tail I want to get rid of, but I cannot use the software to get rid of. So I have to take the snapshot, use the snapshot picture to get rid of that. So that was the result. So that's how I copy back and forth, because I was using different software to get rid of that little tail, right? Why this little tail cannot be there? Because if this tail is there, it will make the green not a function. Do you guys follow me?
Mhm.
So I need to get rid of that green tail, that little red tail. How do I get that little red tail? None of the software can do it for me. This software I'm using doesn't do it, because it will, if you ask for cosine, whether you specify the interval or not, it just give you the entire cosine curve defined on the entire number line. So I have to physically get rid of it. So that's what happened. Okay, that's why, so I have to cross this out. Okay, so this will be, I think this is perfect, right? Is everybody with me?
The arrow you're pointing at is crystal clear from the table to the graph. It's absolutely crystal clear.
Okay, thank you. Okay, so now let's look at the green points, right? Let's look at the green points. You understand how the green points are reflected, right? Over the blue, right? What do you call it? Turquoise, right? It's over the blue. So this point, pi over 3, 1/2, will be reflected over on the other side, which is going to be here, this green dot. So this green dot over here, this green dot, sorry, I didn't come here. This little green dot, okay, which is over, right? This green dot, what is it? That point on the arc cosine, it's half. Okay, I'm going to use the red number half. Okay, half. I just don't write very well with the cursor. I need some more training on that. Pi over 3. Okay? You guys follow me? So on the green dot is, what is the half? The half. Okay, so let me give you this. Okay, so the half is over here on the green. This is the half. You see the red? That's a half. And the vertical is this guy. Now the vertical is the orange. Okay. Now I'm going to do this all over again because this is too many points at once. Okay. So what I'm going to do, I'm going to clean all of that. Okay. If you look at the point on the red, right? That's cosine. You guys follow me? This red piece is a cosine between 0 to pi. And the green piece is arc cosine between -1 to +1 horizontally. Okay, when you look at the points, right? There's a point red, there's a green point over here, right? This green point I points to. I'm going to remove this one as well. Okay, let me get rid of that point. Oh, Jesus, it's much easier just to start over, right? So usually start over again, right? So now, the point we're going to look at, all right? I'm going to bring this point over. I just remove that point, okay? When we look at the points on both curve, right? What's the meaning? What's the meaning? We still look at this piece, right? So from angle to ratio, okay? From angle to ratio, the angle is pi over 3, the ratio is half, and that corresponds to the red curve. So this piece, I'm going to cross it out. Okay, I'm going to cross it out. Now, what is pi over 3? Pi over 3 is a horizontal measurement. It's the arc length. It's a little bit over 1. It's a little bit over 1 numerically, okay? And what is the half? The half is this guy. Okay, I'm color toning with the half on the unit circle. Do you guys follow me? Now, this point will be marked as pi over 3 half. And this red half refers to the red number on the unit circle at a position with terminal pi over 3. You guys understand that? Yes?
Yes.
Okay. So now, you see this blue, this turquoise color, which is a line of symmetry for these two curves. And on the other side of the green is arc cosine. The green is arc cosine. On the other side of the green, okay, there's a point on the green. There's a red point on the cosine between 0 to pi. There's a green point on the arc cosine. And this point, okay, on this point, it's a reversal of the xy swapped. Remember that swap action? Okay, so that the consequence of that swap, okay, that consequence of that swap, so this green point is half, comma, pi over 3. Okay, the orange color refers to the arc length, corresponds to pi over 3, and the red number corresponds to the red number in the unit circle. Do you guys follow me? Now, what is that red half? That red half is this piece. That's the red half. Okay. To make it better, so I'm going to just use the red a little bit up just so that they don't overlap. Okay, so this is a half. And what is the pi over 3? The pi over 3 is this piece. Is that clearer? Is that clear?
Mhm.
Well, because if this is not clear to you, I will draw 2 pictures to do this. Does everybody see that?
Yes, I see it.
How about the rest of the class? Do you guys want some further explanation?
Yes.
Okay. Let's do it. So now, first look at this picture, or look at this table. We did this table yesterday, right? We all did it. Could I assume that? Okay. So what I'm going to do is I'm going to remove this guy, okay? I'll have to do it all over again. Okay, so with this picture, what this picture for? This picture is for cosine between 0 to pi. Okay, so now I'm drawing cosine. Did I draw cosine yesterday? Did I draw cosine yesterday? I did. Never mind, it's not a big deal to draw it just all over again. Okay, so I'm drawing cosine y equals 0, right? I'm going to draw the cosine curve. Wait. Oh, sorry. Come on. What's going on here? Did they draw? Oh, there. So I'm going to bring this picture over. Okay, I'm bringing this picture over to here. Okay, on this picture, I'm drawing cosine. Okay, now what color did I have? Let's see, what color should I have? Red, right? I did red. Did I do red? Yeah, this is the red. Okay, so I'm going to be consistent with that color-wise. You guys are supposed to do the same thing with me. Do you understand?
Mhm.
Okay, so between 0 to pi, okay, so this curve is between 0 to pi, okay, pi, okay, and vertically, I'm going to make this like that. And I'm gonna make a little bit adjustment on that, so it looks a little bit better. So this is the cosine piece between 0 to pi, okay? This is the cosine piece between 0 to pi. How is it being made? How is it made? How is it made? Do you guys remember how is it made? Okay, I'm going to show you how it's been made, okay? Now, you can see this piece is 1, this piece is 1, so I'm trying to be consistent. So this piece is 1, right? This piece is 1. When on this piece of curve, how is the cosine curve made? We talk about in the case of pi over 3, right? We measure from the standard position, pi over 3, right? Counterclockwise measurement, pi over 3. And we pick a point on the terminal sides of the angle. And the red number is a cosine ratio, right? Yes, is everybody listening? All right, so there's an arc length, orange. Okay, so this piece of arc length is stretched straight, okay, pi over 3, okay? And the red number is half, okay? And that point, we have a name for it. Okay, what is the name? Input, output. Input is angle, output is ratio. Input is angle, output is ratio. The first number is absolutely consistent with what we have been doing all along. Do you guys follow me? So the input is angle, which is pi over 3. That pi over 3 is the arc length, okay? It's the arc length because, you know, that's the way we graphed it. And the red number half, this is the correspondence. Do you guys follow me? Does everybody follow me? So this is the making of every point on the red curve. So let me make this red, sorry. Let me make this red. Does everybody follow me? And yesterday we did all of these points. Does everybody follow me? All right, so now I want you guys to put these points on the curve. The red, the orange color is the arc length and half is the red number. Could you guys, did we do this yesterday, Farouz?
I guess we did for the other class. We had more time.
Okay, so then let's do it now. Everybody. So if you understand what I'm doing here, so now we're doing one piece of the curve. Just the arc, just the cosine. This is the cosine curve.
Professor,
Yes?
question. Is it possible we make a label for the x-axis? The unit of the x-axis is in radian, and that is 1 radian, 2 radian, 3 radians.
We can. In that case, I have to invoke another software, which is the decimals.
Okay.
Which is decimals, okay? You guys know what to do. But for this software, no. This software cannot do that. with the different software. Okay, we could do that. Actually, I used to do it, but it just okay. So how about you guys just doing what you need to do right now? That's most. .com.
So Professor, those points from the table can be transferred to the graph 0, 1, and so on and so forth. So
Right.
you have one of them, number 4 on the table is example, you have it pi over 3, 1 half.
Right. Do you guys see that picture?
Mm-hmm.
That's small. Let me get in. Let me get in. Okay, perfect. Okay. The thing is that the screen, I can show you a couple of things. Okay. I want you guys to do it by hand because only by hand can you truly understand what's going on. Do you follow me?
Yes.
To tell you the truth, no one have taught me this. I ended up having to learn this myself. Why? Because none of the professors I had before, they had time to teach this. Okay. So, but I found this very, very important. Okay, I found this very, very important. So for example, cosine x, right? Do you guys see the new thing I have there? The decimals? Some of you know decimals, right? For decimals, we also have the similar struggle. Why? Because you have to cut it. You have to cut it. Let me see if I can make it from 0 to pi. I try to make this process not so long, take so much class time. As I mentioned earlier, it's just so costly in terms of class time. Do you understand? But to make you understand, I'll do it. I'll do it. But everybody must be involved. Because my experience is if I didn't do it myself, I wouldn't understand it. Do you follow me? You can't learn it by watching. You can't learn it by watching. You must have paper, pencil in front of you and you do it and do it and do it. And then I also understand why the professor doesn't do it for us. Because they expect us to do it ourselves. All right? That's the typical situation. So for the cosine piece like this, I'm not giving anybody any excuses whatsoever. But the bottom line is that you have to do it yourself. You have to do it yourself. Okay, so in terms of the scale, I can use the grade. I can use the steps pi over 6, for example. Radians. Well, pi over 6. Okay? You guys with me? So if I do it this way, you have to have the table and the unit circle next to you because I cannot show two things at the same time on the same screen, I think. It's going to be very difficult. Do you guys follow me?
Yes.
Yes.
Okay, so you need to have that. So I'm still going to keep the color tone. Remember the orange Okay, the orange arc length, right? So this piece, the orange arc length. And that piece is the red half. That's all. That's why I didn't want to change in between the software. It's just so much work and takes so much time. Do you understand? So this point, you mark it as input output. The input output, now I can actually use the software to mark it. Pi over 3 half. It will mark it for me. But it doesn't have the color tone. Do you see that? So this orange is the angle, and this is a ratio, the red number. And there's no way I can change the color to be orange and red. So we each have pros and cons. Do you guys follow me? There hasn't been one software for me to use to do everything I wanted. Does everybody get it? So now you look at that table. We're gonna mark all of these points. So how about this point? That point should be what? 0, 1, 0, the radian, 0, 1, right? And how about the next one? That's pi over 6. That's the point I marked incorrectly, right? Pi over 6. Root 3. SQRT maybe. Root 3 over 2. This software actually is as good as it gets. Pi over 6, root 3 over 2. You see, it doesn't show root 3 over 2. It shows you a numerical approximation. And the next one. So once again, it doesn't show that color tone. Okay, so which one do you like? So pi over 6, meaning that if you get the arc length, the arc length is this much. The arc, oh, that's not the right color. The orange color, that's the pi over 6. That's a pi over 6. And that's the pi over 4. Do you guys follow me? They're all the same meaning. You follow me? So all the way to pi over 2. Pi over 2. Pi over 2, comma, 0. At that point, pi over 2. But they give you all these different colors. What I wish for is that their input will be consistently the same color and the output will be consistent, same color. But I cannot make that happen. So when I do it in the other software, I can make that happen. Do you follow me? Same meaning, same color. Does everybody follow me? And you can continue work on that table. Continue work on that table. Okay, so 2 pi over 3. Negative half. There. And the next point. And the next point, 3 pi over 4. 3 pi over 4. Okay, I don't have that table in front of you, but you need to have that table in front of you, okay? That table, it still doesn't show the precise number. So So there, if someone is up to develop some useful software for us math teachers, here you go. Okay, then 5 pi over 4. 5 pi over 6. Okay, and then that's negative root 3 over 2. Okay, and the last one, of course, is pi negative 1. Okay, but for our purposes, right, this number should be orange, orange, orange. My orange refers to what? What does my orange refers to?
The arc lens.
That's right. That's what you understand why I want to keep that consistency. And these numbers should be what? These numbers I wish to be red. That will be fitting to my description, consistent with what we have been doing. Do you guys understand that? But this software has a disadvantage. It doesn't give me the precise value which your professor wanted. Okay, all your nerdy professors in all the departments of mathematics all over the world, they want that precise value. Okay, so these numbers should be the, these precise values. So when you mark it, okay, when you mark it, you should mark it the way I mark it in the previous software. All right? Do you guys follow me? Because in the emphasis of my lecture is to emphasize what's the input, what's the output, the meaning of each entity. The meaning of the entity, right? The orange color has the same meaning, which are all the input. The red are the output, and those red numbers correspond to the numbers on the unit circle. Did I make myself clear?
Yes.
So that's ArcCosine. That's the cosine between 0 to pi. Okay.
Thank you, Professor, for this software. It shows the x-axis in radian and crystal clear conversion, exact values, ratio into decimal equivalent. That's wonderful. Thank you, ma'am.
Well, this is not a problem. I used it before. It's just I'm not happy with the number here. Okay, these numbers should be substituted by the precise value. Do you guys understand? Okay, so when you do it, right? So let's go back to the picture, right? What will be my desirable situation that I want to show you, right? So you have seen both sides of the story. So if we go back, okay, if we go back, how do we want to mark those points? How do we want to mark those points? Suppose I will make all those dots, right? Remember the case I have it done. I wish to mark each point the following way. Okay, for example, this dot, which is pi over 3, right? Pi over 3 is the angle. I wish that to be marked this way. The first number is pi over 3. The orange corresponds to the arc length. The red number is a red number on the unit circle. And I wish every point is marked in a similar manner. Do you follow me?
With the exact values, as we see, root 3 over 2, root 2 over 2. So
I want to see the exact value. So when remember that picture, I made that mistake. I was trying to do that. I haven't found a software that would do it for me. So I'm doing this because this would be in the way I lecture, in the way I emphasize would be most fitting and make the most connection. So, but anyway, did I make you understand?
Yes.
Okay. So now with that said and done, okay, did you guys mark all of the points already? Have you guys marked all of the points already?
Mm-hmm.
Is that everyone? Or are you still working on it? Okay. So what I'm going to do is I'm going to do this. I need everybody to do this. I need everybody to do this. Okay. I want you guys to mark all of these points in the way I want it. Okay. You see that other alternative, right? It give you marking, but essentially you have to do it the way I think is the best way, even though the writing is not that perfect. Okay, so I'm going to mark these points to the best of my ability. Okay, so that's red dots, right? Red dots and 0, 1. Uh, 4 pi over 4. This is root 2 over 2. And the next one, pi over 3, half. Next one, pi over 2, 0. The next one, 2 pi over 3, negative half. Three pi over 4, negative root 2 over 2. Because I do want to give you a version of my preferred form. Okay, I hope everybody have caught up with it. So this is negative 1. So we get all the red dots here. How do I want you to mark it? Okay. I want that to be put on the record. Okay. Now, every point, okay, every point, wait. Clear it. I'm going to make every single point. Okay, every point has an input output. Okay, input output. Input output. Input output. Okay, input output. Every point. Input output. Input output. Input output. Okay, the last point, we also has an input output. Okay, so what I want you guys to see with the orange color, arc length is being 0, arc length is being pi over 6, arc length being pi over 4, arc length being pi over 3, arc length being pi over 2. You guys get it? 2 pi over 3. And this is 3 pi over 4. Pi over 6. Like we emphasized yesterday, it's about understanding. It's about understanding. It's not about memorization. And the red number Red number 1 goes here. Red number √3/2 goes here. Red number 1/√2 goes there. Red number 1/2 goes there. Red number 0 goes there. Red number -1/2. Do you follow me? Red number 1/√2 negative. Red number -√3/2. Okay, and eventually red number -1. It's not done perfectly, but it meant to make the connection. And I expect you guys write it better than I do on your paper. So what do these orange color refer to, Jacob?
It refers to the arc angle. On the
That's right. That's so I wish you guys to see that consistency. Okay, and the red number are the red numbers on the unit circle. You follow me? So that will be the color tone I want for better understanding. You guys follow me? All right, so are we good with this episode? So let's look at the other piece. Shall we? Once you get this part, the other piece is easy. The other piece will be easy, okay? So did you guys write it down? With your whatever, I hope you use the same color, right? I hope you use the same color, but if you don't have that color, that's okay. Is everybody with me? I'm about to erase it. Are we good? Could I erase it now? Did you get the point?
Yes.
Thank you. Now, so let's look at the ArcCosine. Okay, for ArcCosine, I'm going to make, we have the ArcCosine table, don't we? Where's the ArcCosine table? Right here. So we did the cosine between 0 to pi. Let's look at the ArcCosine, right? So we did the reversal, right? X, Y swapped, right? X and Y swapped, yes? And these are the consequences of swap, right? What's the consequence of that swap? What is it? For cosine, right, for this table, I'm still going to bring this table with us. Okay, for this table, its angle is the input and ratio is the output, right? Ratio is the output. Cosine A, and it comes out as ratio. And on the other one, ratio is the input, and it comes out ArcCosine. Okay, ArcCosine. X, it produces angle. It produces an angle. So these points will be ratio angle, like we pointed out over there, right? Ratio to angle. So ratio to angle, we know that when we try to find inverse, what do? We swap X, Y, right? What is swapping X, Y means? It's swapping input with output. So input becomes output. Input becomes output. If you look at the first row, right? If you look at the first row, input becomes output. Output becomes input. Input becomes output. Output becomes input. Do you guys see that? That's the meaning of ArcCosine. Do you follow me? And ArcCosine has to be a one-to-one function, just like cosine in from 0 to pi is a one-to-one function. Is everybody with me? 1 to 1, okay? It cannot be 1 to 2, 1 to 3. It cannot be 2 to 1, so it's 1 to 1, okay? Exactly 1 to exactly 1. You follow me? So that swap will cause what happen? What to happen? That swap, if I bring that picture over here with me, okay, if I bring that picture with me, it was 0, 1, right? So 0, 1. 0, 1, when we swap, it becomes 1, 0. What will be the effect if I plot 1, 0? 1, 0 in green. Right there. You follow me? This is 0, 1, and this is 1, 0. Do you see that? Do you guys see that?
Mm-hmm.
So 0, 1 means what? 0, 1 means the orange is 0. The ratio is 1. The ratio is 1, okay? The ratio is 1. You follow me?
Yes.
With that swap, 1 is ratio. Orange becomes the angle. Input output swapped. Do you guys see that? Does everybody see that? Remember the orange color we did for angles, right? Now angles become the output, ratio become the input. So ratio 1 was the cosine ratio. Now it's ratio 1, and the angle is 0. The radian, the arc length is 0. Got it? Let's look at the next point. √3/2, pi over 6, right? It used to be pi over 6, the input, the output is ratio. Now we swapped. Remember that swap? That swap causes domain range swap. It also caused every point and their meaning and their position swapped, okay? So that swap implicate so much things. So let's look at the next point. The next point, right? Input becomes output, output becomes input. So this point is going to be on the ArcCosine. Oh, wait. Okay. Add a green dot. Do you see that green dot? Do you see that green dot?
Mm-hmm.
Okay, that green dot, how would you mark that green dot? It's √3/2, pi over 6. Let me put an arrow, green arrow. Okay, this is the point. And what is the corresponding red point? Right there. You follow me? Does everybody follow me? So that orange red become red orange. Do you follow me? That's the meaning of inverse. Jacob, Nicole, did you guys get it?
Mm-hmm.
All right, so this is the same for all of the rest of the points. Okay, for example, for pi over 4 to root 2 over 2, it's right here. And after the swap, what do we get? Oh, we haven't plotted that point yet. Okay, so let me plot that point. Okay, I'm going to plot that point. Is it going to be a green dot? Okay, do you see that green dot popping up? That green right here. You guys see that? And they are on both sides. They are on both sides of that line of symmetry. I'm going to use turquoise. They're on both sides. So turquoise, I should make it broken line. It's on both sides of that. This, because the scale is not perfectly set. It should be, see, this red corresponds to this green, and that green corresponding to that red. You guys see the points? And you need to mark the points properly. Okay, you need to mark the point properly. So with that said and done, let's do some marking to enhance our understanding up to now. Okay, are we good? So far, so good? 0, 1, 1, 0. That's all good. So let's look at these two pairs. This red and this green. Okay, this red should be marked. You guys should mark it with me. This red, I'm going to use orange color. It's pi over 6. And this point, the red number is √3 over 2. Okay, that's just for this point. Okay, this green, what about this green? This green, we started with √3 over 2. And the orange is pi over 6. Okay, they are on both sides. Okay, they're on both sides. So this guy is over here. Whoops. This guy is the green, and that guy is the red. Is that clear, everybody? Is that clear to everybody? That's the consequence of swap XY. And they're on both sides of the turquoise broken line. Any questions? Or am I too slow? I know I'm too slow. Yes? Are you with me? At least if I can get you guys to understand it, then I'll be amazing. Yes?
Yes, I'm still here.
And these two pairs, the green and red, you look at the green and red, right? This red is going to be marked. This red, okay, is going to be marked as the orange pi over 6, pi over 4, sorry, comma, red number root 2 over 2. If I'm in the classroom, I bet I will do a better job. Okay, green, the green dot here. Okay, this green dot should be marked as root 2 over 2. I'll put the orange color pi over 4. You get it? Did I already get it? Did everybody get it? Huh?
Mm-hmm.
Do I see any feedback? No feedback on chat. So should I assume, is everybody there or some people are out on the beach?
I'm here.
Oh, I know you're there. Thank you. So where's everybody else? Yeah. And this is the same for every point. And that's the implication when we find inverse. Remember, there's the first step of finding inverse. What did we do? What do? We swap x, y. That swap implicates not only the domain range swap, it also implies all the points on one curve is swapped to the other curve. How many points on each curve? Infinite. There's the infinite swapping taking place. Do you guys follow me? Swap, swap, swap. You got it?
Mm-hmm.
All right. So when we connect those green dots, right? I didn't do pi over 3 this time, but pi over 3, the same thing. Same thing. Okay. Do you think I don't have to do all of them for you, or you guys will do the rest? Could I expect that? Because there will be some points on the other side. Okay, there'll be some negative numbers. So let's look at some negative numbers. Okay, let's look at some negative numbers. So did you guys write this down? Did you guys write these down? Because before I clean up.
Yes, I wrote it down.
Thank you. All right, because this piece will need to be flipped over too, right? We just flipped over these pieces, and this piece is also flipping over to the other side. It's flipping over to the other side. So what do we get? Okay, so keep going. So these pieces is going to also flip on the other side. So this point, what's the coordinate of this point? Everybody tell me. If you understand what I'm doing now, you should be able to tell this point, the coordinate of this point right away. I want to see some answers on chat. What is the coordinate of this red dot, red heart?
That
And
should be pi over 2 and then apostrophe 0.
That's right. That should be pi over 2 input from here. You got it, Jacob. Okay. So this point is right here. So if 0 comma pi over 2, where would that be? What would be 0 comma pi over 2? Where would that be?
It would probably be on the y-axis.
That's right. It's definitely on the y-axis, somewhere over there. Yes. All right. So now with that understanding, okay. With that understanding, so you anticipate there's a point, a green dot, which is 0 comma pi over 2. 0 comma pi over 2. You should have some anticipation as where it should be. it should be a green dot because it's on the green. The green is ArcCosine. That's a green dot. And that green dot corresponds to what point? Red, green. So can you guys mark these 2 points for me? Can you mark these 2 points for me?
For the green dot. Oh, never mind.
Go ahead. Meanings are different. On the red, which is a cosine, the input is angle, the output is ratio. Its inverse, the input is ratio, the output is angle. That's what we're trying to emphasize here. That's right here. Do you guys follow me? Consistent, consistent, consistency. Yeah?
Mhm.
So how about you guys keep going? You guys keep going. You plot the rest of the points, the rest of the green dots. Okay, and I'll be doing the same. I'll be doing the same. I will do it just alongside of you. Anybody want to go with Farouz?
Professor, right here, do you see option says labeling in your software?
Sorry?
When you plot right here in this sub screen, I mean the sub window, I see the option says labeling. Is that the probability like you can label all those points you?
That's what
plot?
I was saying. To label them properly, it's very time consuming.
Oh, okay, okay.
Okay, I was doing labeling.
Oh my God, okay.
I have to identify. You see the software here?
Yes,
For anything I label, I have to identify the points. I have to change, I make sure the color works. It takes me
Wow.
one time to get one
That's
point
right.
in the right place. So that's
That's
why
right.
I hesitate to do it in class, because it's going to take 3 times the time of class time.
I see that. Thank you.
No problem. So I did it outside the class. But as a consequence, it just,
You just got the typo, that's it.
yeah, I just got a typo. So you can see if I label each one of these, I need double the class time. I don't think you guys want to wait for me for that. That's too long. Okay, that's too long. Okay, you guys follow me?
Mhm.
So first of all, I have to cross out these pieces, because these pieces, as I said, no software will plot cosine from 0 to pi alone. Some software might be able to do that. I suspect scientific Mathematica might do that, okay? But Mathematica has other inconvenience, so it just I don't want to deal with 2 software at the same time. So this little tail should be crossed out because that's outside the 0 to pi. Okay, do you guys understand that? I don't want to confuse you in any way. Why am I must cross it out? Because otherwise it's make the green function not a function, okay? So next I'm going to connect the dots for the green. Okay, arc cosine x. So this is going to be green. This is going to be the green. So this piece, right? This bottom piece, the red is flipped over to the other side. And next, I want you guys to mark the points. Could you guys mark the points? For example, negative half 2 pi over 3. What is negative half 2 pi over 3? Right there. Okay. What is 2 pi over 3? Comma negative half over there. Okay. So let me mark that as an example for you. These points. This is 2 pi over 3. Comma, negative half. Negative half should be in red. All these coordination. Okay, negative half. And this point is negative half, comma, orange, 2 pi over 3. Is that clear, everybody? We're still dealing with the swap. We're still dealing with the swap. The implication of swap. So this is what I meant. When mathematics says something, it implies a lot of information. It has a consequence in a big range of issues. You guys follow me? So we have to think a little deeper. We have to think a little deeper, right? So far, so good? So that is going to be true for every point. So this is going to be for 3 pi over 4, you know, negative root 2 over 2. And that point is going to be negative root 2 over 2, comma 3 pi over 4. So that's the consequence of swap. That's the consequence of the swapping of input output. You guys see that? That's the consequence. That's the consequence of swapping input output. If you don't think about these, if you don't think about these details, how can you get those points? How can you, because if you don't think about this, the professors who's fixing questions on your exams, he will or she will. And then you have to think on the spot. How much time do you need to think on the spot? And you only have limited amount of time on an exam. So I'm basically showing you how to think, how to dig deeper about. And so far, we haven't gone out of ARD. We started talking about ARD, for how long? Weeks already, right? Have we gone out of ARD? Not at all. Not at all. Okay. All right, so I think you guys can deal with the rest of it, right? So that's ArcCosine. That's ArcCosine. Oh my God, we reached the end of the class. Do you think you guys can do the rest of it? Well, you will have to do it because you have homework. And your quiz is also related to it. And quiz number 16 is coming up. Okay, I'm going to double check to see I made a typo there. Now, making labels on this software I use, which is very convenient for a lot of things I do in class. Okay, you can see, right? You guys probably enjoy the typing, right? Everything is very clear. But the labeling is my headache. Labeling is my headache. So I have to do the labeling after class, do that for a long time to make it right.
I thought the software must be equipped automatically when you give the points, then the software, if you hit the label that point, the software should automatically label it correctly, but it doesn't.
Well, that's up to someone else in the future to invent a software for us.
Yeah, or upgrade this software, upgrade version 2.0.
The department is not, the school is short of money. The school is short of funds.
Professor, while we are here, you mentioned about that extra part of the cosine function you exited on the graph. Could you mention that? I want to just double check. You said you cannot restrict the domain for graphing. You cannot restrict the domain for 0 to pi only and graph that portion of the cosine?
I tried, it didn't work.
It didn't work.
It didn't work. Yeah, I don't know. I will try again because yesterday I tried it.
We might be like it today.
Well, I can try. So I typically don't want to spend time, your class time to do these things.
Since we are in the end of the class and kind of like a couple of minutes.
You see here, if anywhere we can do that. I actually can see there's a
option axis, no?
I will try another way. I will try with piecewise function. Okay, I will try with piecewise function. But as of now, see if I put this over here, right? If I put a 0 pi.
How about the axis? Do you see the option axis? So you can say on x axis.
It doesn't do it. The X here?
No, on the previous screen you were on the screen. You were in the window open.
Here?
Yes. You see axis above axis option? Yes. Maybe over there.
Option.
Maybe you could restrict the x-axis. Is there any option to do that?
No. This is about tick mark. Okay. These are about the red lines. And they don't. What I did is I removed the view.
Yes,
from the view.
View is good too.
The issue is that I want to see this piece. So right. I need up to -1.
That is right.
So if I show -1, they will show me both pieces. So I cannot say I'm only showing this piece, not this piece.
Right.
The software doesn't do it for me. Or I don't know how to do it.
So you are using the software. We are learning how to use the software in the 7th weeks of the semester.
You guys don't need to learn the software. Learning this software is no use to you guys. Okay, you guys graduate, you never use this software again. Okay, The only place I think you can use this software is to calculate your mortgage payment or your car payment. But for that purpose, you don't need the software. You don't need to spend money to buy this software. The calculator usually has a built-in, and your broker will have that calculated for you. Why do you need this software? You don't need this software. Okay, only for teachers, for math teachers, we find this software useful.
Yes, ma'am.
Right?
Yes.
Otherwise, who's buying scientific notebook for math teachers for your daily life? No, don't spend that money. Okay. When the school is open, this software is available. I think it's available in the school's computer, in the math department. If you want, if you need to use it, I mean, for you guys as a student, if you want to learn a math software, okay, you guys in STEM, the software you learn is MATLAB. Okay, it's MATLAB or some other software that may be useful for your future career. I wouldn't promote this software for anybody. Okay, this is pretty old software. It's what you see, what you get. It types the mathematical notations well. That's why I use it. Okay, it typed the mathematical notation well. You see, it typed these functions well. It typed the intervals, and it has a lot of great features, but it's not perfect. Okay, it's not perfect to suit all of my needs. But anyway, we've been doing this for too long. So tomorrow we will continue. Right. So are we clear, everybody? So looking ahead, what are we going to do? Tomorrow, we're going to do the following. Tomorrow, we're going to apply this piece. Okay, which is referred to trig 7a. We're going to apply this piece to cosine and ArcCosine, to these two functions. Okay. Actually, I already did this for my other class. I can post their recording on your module as well. So you can watch it and you can learn and you can start working on 7a, trig 7a. Would you want me to do that?
Wait, you mean the homework?
Yeah. Because we're a little slow today. We're slower than we. I'll post it anyway. You watch it, you don't watch it, but we're gonna cover it yesterday. But we're gonna cover tomorrow anyway. Okay, then we're gonna finish up tangent. So for entire basic one, at the end of week 7, we're gonna finish them all. Okay, so that's the plan. That's the plan. All right, I will see you guys tomorrow.
Thank you very much, Professor.
Thank you.
Thank you. Have a nice day. I'll see you tomorrow.
You too. Good job. Wonderful.